And welcome back, students. Let's continue to talk about input devices. Today we're going to talk about the classic computer mouse. So getting started, a computer mouse is a handheld pointing device that detects two-dimensional motion relative to a surface. This motion is typically translated into the motion of a pointer on a display. Usually that's our mouse cursor, which will allow a smooth control of the graphical user interface, or GUI. So for example, like right now I can move my mouse cursor around. That is the pointer. And in the display, of course, the GUI is just your screen. Now, originally, keyboard mice were wired to a computer, whether it was through PS2, USB, whatever. However, modern mice are often cordless. Like, for example, this laptop right now, this mouse pointer is a wireless mouse. So it uses short-range radio communication that's often connected to the system, either through infrared or some kind of radio frequency. Now, let's talk about the different mouse components. Mice originally used a ball rolling on a surface in order to detect motion, but modern mice often have optical sensors that have no parts. Which, to be honest, as someone who remembers the old ball mice, it's pretty handy because then you don't have to go and you don't have to open up the tracking ball and clean it out because your wheels are going to fill with dirt and stuff like that. So it's pretty nice. In addition to moving a cursor, computer mice have one or more buttons to allow operations such as the selection of a menu item on display. Pretty standard fare is for mice to have 3 buttons, which we'll talk about here in a couple minutes. It used to be, with the very first computer mice, though, it had 1 button because it only needed to do a click operation. Time went on, then we went to 2 buttons because we wanted to be able to do a selection, and we also wanted to be opening up this contextual menu. Now, mice often feature other elements such as touch surfaces and wheels, which enable additional control or dimensional input. Now, the relative movements of the mouse on the surface are applied to the position of the pointer on the screen, which signals the point where actions of the user take place, so hand movements are replicated by the pointer. Now, what you want to happen is going to be the position of where that mouse cursor is. Now, clicking or hovering, which is stopping movement while the cursor is within bounds of an area, can select files, programs, or actions from a list of names, or in GUI elements, through small images called icons or elements. For example, a text file might be represented by a picture of a paper notebook, and clicking and while the cursor hovers this icon might cause a text editing program to open the file in a window. Let's continue to talk about mouse operation. Some different ways in which the operating mouse can cause specific things to happen within the GUI. You have a single left click, which is simply just clicking the main button. You have a left double click, which clicks the button 2 times quick succession, which counts as a different gesture than 2 separate single clicks. You also have the not so often used triple click. It's often not really used because it's very hard to differentiate a triple click from a double click or 3 clicks. But this is 3 quick times in succession, try saying that 10 times fast, as a different gesture than that of 3 separate single clicks. You also have the right click, which clicks the secondary button, or in some mice it click with 2 fingers, depending on how you have your mouse mapped. This will bring up a menu with different options depending on the software. And then you also have the middle click, which is clicking the tertiary button. This is often, for example, where your scroll wheel is on your mouse. So if you were to push down on that scroll wheel, it clicks, and because that counts as the middle click. You also have the ability to do drag and drop, which is pressing and holding a button and then moving the mouse without releasing. We also have a mouse button coordinating, or what's known as rocker navigation. This is a combination of a right click followed by a left click, or the combination of left click then a right click or keyboard letter, the combination of left or right click as a mouse wheel, or clicking while holding down a modifier key such as Alt or function. Also, we could talk about moving the pointer a long distance. When the practical limit of a mouse movement is reached, one can lift up the mouse, bring it to the opposite edge of the working area while it's held above the surface, and replaces it back down on the working surface. This is really, really crucial here because your working space may not be that large, but the mouse is not limited to that. So just because let's say you only have a, let's say, 9-inch by 9-inch working area, it doesn't mean that you're going to have a 9-inch by 9-inch area to correspond to your screen. All right, let's talk about optical and laser mice next. Now, most mice today are either optical or they're laser. Optical mice rely entirely on one or more light emitting diodes or LEDs and an array of photodiodes to detect movement relative to the underlying surface, skewing the internal parts of mechanical mouse used in addition to its optics. Remember, we're talking about mechanical mouse, that's usually the ones that have the old tracking ball inside of them. Now, a laser mouse is an optical mouse that uses coherent or laser light. All right, real quick, let's talk about connectivity and communication, particularly the PS2. That would be this symbol right up here, the green one right here. The purple one is for a keyboard. Now, PS2 mouse will communicate motion and the state of each button by means of 3 byte packets that are sent directly into the motherboard. For any motion, button press, or button release event, a PS2 mouse sends over a bidirectional serial port a sequence of 3 bytes, as I already mentioned. This standard, of course, though, has been largely replaced by USB. You'll still find some PCs that have it, and with older PCs, if for some reason you're having driver issues, you can always plug a PS2 mouse or keyboard in just to get some functionality while you try to troubleshoot those driver issues. Newer computers are often don't have PS2 because everything now has built-in support for USB. Let's also talk about cordless or wireless mice. Cordless or wireless mice transmit data either via infrared radiation or a radio frequency, such as Bluetooth or Wi-Fi. Now, the receiver is connected through a USB port, or it can be built in. The built-in is usually for more like your things like Bluetooth. Now, some of these receivers can be stored inside of a mouse for transport when not in use, or designed to be small, so being plugged into a laptop while transport. So, for example, my wireless mouse right now has a small receiver on the laptop, and it's just a USB one. I just plug it in, but the actual piece that sticks out of the laptop is probably only about a half to a quarter inch. And sometimes they make them smaller, sometimes they make them larger. It just depends on the model. But that piece can, of course, be stored also inside of the mouse if I want. But because it's small enough that it doesn't like stick out profusely, I could actually leave that in there without worrying about damaging it. While I just move the laptop, I might put it in my bag or whatever. And I don't have to worry about it getting damaged because it's so small that it's pretty much acts almost like it's just another part of the machine. All right, talk about mouse button. The 3-button scroll mouse has become the most commonly available design today. You can still find 2-button mice. However, most people agree that probably without the scroll wheel, you're probably going to go nuts. Users most commonly employ the 2nd button to invoke a contextual menu in the computer software's user interface, which contains options specifically tailored to the interface element over which the pointer currently sits. So what that means is that when you right-click your mouse, whatever happens with that right-click is going to depend on which software application you're currently in. So, for example, if you're just in the desktop of Windows, it's going to bring up a prompt there. But if I'm in a video game, a right-click might correspond to, for example, canceling an action. It just really depends on what software is currently active for that mouse press to correspond to the appropriate action. Now, by default, the primary mouse button sits on the left-hand side of the mouse, and for the benefit of our users, because most people are right-handed. However, left-handed users can usually reverse this configuration via software, or you can even buy left-handed mice. So if you're a left-handed person, you struggle with right-handed mice, you can actually buy a left-handed mouse to benefit you. Now, aftermarket manufacturers have long built mice with 5 or more buttons. And this is really handy because software can map mouse buttons virtually to any function. It doesn't have to be restricted just to clicks or scrolls or anything like that. So you can do any function, keystroke, application, switch. Extra buttons can make working with the mouse much more efficient and easier. One of the most common things you'll see people do with them is with a mouse button. You might have a macro script, for example. So when they press that mouse button, it runs the macro. All right, next let's talk about the scroll wheel. Now, a scroll wheel or mouse wheel is a hard plastic or rubbery disc on a computer mouse that is perpendicular to the mouse surface. It's normally located between the left and right mouse buttons. Occasionally you'll see it in different locations, but most often that's where it's going to be. It can also be used as a third mouse button by pressing on it. If you've ever done it, you press down that mouse button and it goes click. Sometimes it'll bring up things like, for example, a scroll. So you might be able to scroll up, scroll down, scroll left, scroll right. Just kind of depends upon the functionality of the mouse and also the software that's currently running. Now, the wheel is often engineered with detents in order to turn in discrete steps rather than continuously as an analog axis to allow the operator to determine how far they're scrolling. So if you ever take a mouse and you scroll it, you'll know that when you scroll that mouse, it doesn't just continuously turn non-stop. You can feel that there's almost like little, I want to call them bumps in there as you turn, which helps you indicate how much you're turning the wheel. All right, and mouse speed. Mickeys per second, yes, it is literally called Mickeys per second. I'm not making this up. Is a unit of measurement for the speed and direction of a computer mouse. Now, speed can also refer to the ratio between how many pixels the cursor moves on the screen and how far the mouse moves on the mouse pad, which can be expressed either as pixel per Mickey, pixel per inch, or pixel per centimeter. Most common one that you usually hear is pixels per inch in my experience. Now, the computer industry also measures mouse sensitivity in terms of dots per inch, or you'll hear also CPI, which is counts per inch. So the number of steps the mouse will report when it moves an inch. So the higher the CPI or DPI, as I mentioned above, the faster the cursor moves with mouse movement. And that concludes our notes on the mouse, folks. Until next time.